Welcome back to another video, Daishinfinity video. In this video, we're going to talk about the derivative of the inverse of secant. So the inverse of secant is the same thing as 1 over the inverse of cosine, also known as arccosine of x. In this video, we're going to talk about the derivative of this function. Now, before we dive right in, we have to take in consideration the definition of a derivative of f of x. So the derivative of any function f of x is equal to the limit as h approaches 0 of the function with x plus h as an input minus the function f of x all over h. So since our function is secant, inverse secant of x, we're just going to plug that in. So it will become our limit as h approaches 0 of the inverse secant of x plus h minus the inverse secant of x all over h. Now, if we deal every time with some inverse functions, I would rather substitute it with an angle, since the inverse functions, they always demonstrate the angle of any given function. So now let's set theta 1 to be equal to the first one, so secant inverse of x plus h, and theta 2 equal to the secant inverse of x. So it will become our limit as h approaches 0 of a very simple limit, x plus theta 1 minus theta 2 over h. Now we cannot really calculate this limit, since when h approaches 0 it will explode to infinity. So we are just going to try and look back to our normal mathematical equations we can take in consideration, so that we can have some benefit for this limit. So as for the secant line passes through 2 points at a specific function, and the gradient of the secant line is, of course, when we want to take the gradient of a line or any function, the gradient of any function at a given point a is equal to the limit as x approaches a of f of x minus f of a all over x minus a, which means we can take a to be theta 2 and x to be theta 1, because if theta 1, which is the inverse secant of x plus h, approach theta 2, it should mean that h should approach 0, because if h approaches 0, theta 1 would approach theta 2. But it is our case because the limit is having the index x, which goes to 0. So we can use this as a normal function and say that the derivative of secant at the point theta 2, we will call it at, like, let's just call it a point, is equal to the limit as theta 1 approaches theta 2 of the secant of theta 1 minus secant of theta 2 all over theta 1 minus theta 2. Now, since h approaches 0, it is definitely true that theta 1 approaches theta 2, so we can actually ignore this limit and continue with our calculation. So with some algebraic multiplication and division, we can get that theta 1 minus theta 2 here, just swap them, is equal to secant theta 1 minus secant theta 2 all over the derivative of secant at the point theta 2. Now, what is the derivative of secant of x? The derivative of secant, which we already did in another video, is the same thing as the secant of x tangent of x. So we're just going to substitute the theta 2 into our equation. So it will be theta 1 minus theta 2 is equal to secant of theta 1 minus the secant of theta 2 all over the secant of theta 2 tangent theta 2. Now, we previously substituted as theta 1 is equal to the inverse secant of x plus h, which indeed means that secant of theta 1 is equal to x plus h. And the same thing goes for theta 2, that theta 2 was our inverse of secant of x. So if we take the secant on both sides, we'll get secant of theta 2 equaling x. So we can plug the x here and here and here for x plus h and x. So we would get another expression, theta 1 minus theta 2 is equal to x plus h minus x all over x times the tangent of theta 2. X will cancel out and we would finally get x over, sorry, not x, it will be h, I'm sorry for that, h over x tangent theta 2. Since we have this one, we can go back to our limit, which states that our limit was indeed the limit as h approaches 0 of theta 1 minus theta 2 all over h. Also stating that we have h over x tangent theta 2 times h, where the h will cancel out, which means we can leave the limit behind. That's why I didn't really write the limit at the first place here. So here we get 1 over x tangent theta 2. So we still have the theta 2 here, and theta 2 indeed was the inverse secant of x. But the tangent of the inverse secant of x we cannot really calculate. So we just have to get another way of writing the tangent of theta 2. Now indeed we know that tangent of theta 2, or tangent of x, indeed is sine of x over cosine of x. So we can use this to express tangent of theta 2. Now we know indeed that secant of theta 2 is equal to 1 over cosine of theta 2. Now secant of theta 2 was x. So if we swap the x with the cosine of x plus theta 2, multiplying cosine of theta 2 on both sides and dividing s on both sides, then we would get that cosine of theta 2 is 1 over x. So we have an expression for cosine of theta 2. Now we want an expression of sine of theta 2 regarding the fact that we already know cosine of theta 2. How can we express sine of theta 2 using cosine of theta 2? Of course, very easy. We know that sine square theta 2 in this fact plus cosine square theta 2 is equal to 1, which means if we subtract cosine squared theta 2 on both sides, we get sine squared theta 2 is equal to 1 minus cosine square theta 2. Now what is cosine square theta 2? It is the same thing as 1 over x squared. So 1 over x squared, and now we're going to put this into the same denominator so that we can get a unified fraction, which would mean we have secant sine square theta 2 is equal to x squared minus 1 over x squared. Now we can take the root on both sides so that we get rid of the squared here. Then we get the sine of theta 2 is equal to the square root of x squared minus 1 over, now we have to be careful because the x squared is always positive on all of the real numbers, which means we have to always take in consideration that the square root of x squared is equal to the absolute value of x. Now since we have sine theta 2 and cosine of theta 2, we can say that tangent of theta 2 is sine theta 2 over cosine theta 2, stating that we have the square root of x squared minus 1 over the absolute value of x over 1 over x. Now this will theoretically mean that we have to multiply with the reciprocal, so we get square root of x squared minus 1 over theta and then times x. Okay, so this is our expression for tangent of theta 2. Now let's put that into the final expression, 1 over x tangent of theta 2 which should be the derivative of the inverse secant. This would equal to 1 over x times the square root of x squared minus 1 over the absolute value of x times x, which means 1 over x squared times the square root of x squared minus 1 over the absolute value of x. X squared is always positive on all of the real numbers, so we can theoretically, mathematically cancel one of the x's here, which would become the absolute value of x. So we get 1 over the absolute value of x times the square root of x squared minus 1. And this is our formula for the derivative of the inverse secant of x. I hope you really like this video. Please like and subscribe, and let's see us in the next Daishinfinity video. See ya.